Alright, so let's get our flowcharts back out. Take a look at it again. We've been deciding on the number of terms. So the first thing was always GCF. Does it have it? If it does, factor it out. Whatever. Now you move on to how many terms that it has. We did 2. Now we're going to skip over there to 4 terms. I know it sounds weird. Why didn't we go to 3? Well, 3 is what the whole next lesson is about. It has like the most kind of possibilities in it, so it's going to be separated into a whole bunch of different videos. Anyway, so we're going to look at the 4 or more case. Okay, so we're going to do it. If you take a look at that diagram, it says factoring by grouping. Can we do it by factoring by grouping? And that's what this objective is going to be about. If you look further than that, if you can't, then you're going to use synthetic division, and that's something that we're going to learn how to do in the future. Right now, we're just talking about factoring by grouping. So, objective 3, you're going to be able to factor a polynomial by grouping. So take a look at this picture here. Some maybe Polaroid of somebody's intimate Christmas experience or something. And if I look at the grouping of kids down there, maybe I go, well, they don't all have something in common. However, if I take them in pairs, each of those pairs have something in common. So for example, if I take the 2 girls, each of those 2 girls wearing a sweater buttoned up at the top, and if I take the 2 boys, they're both wearing a V-neck sweater individually. Okay, so that's what you're doing whenever you're factoring by grouping. So look at this polynomial right here. We have x cubed plus x squared plus 2x plus 2. And you take a look and you go, hey, this thing does not have a GCF. There's nothing that every single one of those terms has in common. Okay? However, if we group it, we group the first 2 together and we group the second 2 together, each of those individual groupings will have something in common. That can be factored out. So take a look. So if I group up the first 2, the x cubed and the x squared together, and then I group up the 2x and the 2, what is common to the first set of parentheses there? I got an x cubed and an x squared. Well, in common they have an x squared, so I can factor that thing out. And in the second set of parentheses, what they have in common is a 2. So that's what you're going to do. In first set, you're going to factor out an x squared, and you're left with a quotient x plus 1. And on the second one, you're factoring out the 2, and you're left with a quotient x plus 1 again. Okay? And this is what we want to happen if we're factoring by grouping. Okay? Once we've factored out that first GCF from each of those groupings, then what we're left behind, each of those quotients, if they match up, then it is a new GCF for that polynomial. And it's going to be factored out, right? So this new expression has a common factor of x plus 1 that we can factor out. Okay? So when we do that, I factor out the x plus 1 from each of those terms, and what's left behind from the first one is x squared, and what's left behind from the second one is plus 2. So now we have just factored that cubic polynomial, 4 terms, we factored it by grouping. Okay? So in factoring by grouping, you're going to want you got to group the terms so that each of the pairings has some sort of GCF that you can factor out. Hopefully, after you've factored out that first GCF from each of the pairings, what you're left behind, each of those quotients, makes a new GCF that you can factor out. If it doesn't, you can't do the thing by grouping. Okay, another thing is that you may have to rearrange the terms so that your pairs have something in common. Okay, it may not always be exactly as you see it in the order that is given to you. Okay, and then just like we've seen before, you want to check to see if each of the sets of parentheses, each of the factors are prime at the end. So if I look at the one that I have here, the x plus 1, it's linear. A linear one is going to be prime. Unless what they have in common is maybe some sort of number. Okay, if I look at x squared plus 2, this one is also prime because it's a binomial and it's not the difference of 2 squares. So that's it. That's as far as that one can be taken. So let's try a couple of these where we're factoring by grouping. I've got 4 terms here. I don't have a common factor overall, but maybe if I group them up in pairs, they will. So let's just try the order that is given. Okay, so if I try the first two and I try the second two, I can see in the first set of parentheses it has a common factor of x squared. So I'm going to pull that out, x squared. And if I divide both of the terms in the first set of parentheses by x squared, I get 2x. And then for the second one, x squared divided by x squared is plus 1. Okay. Now, if this is the right pairing of things, and if I can do it by grouping, the second set of parentheses is going to have 2x plus 1 in it. So let's see. Now, if I look at the 32x plus 16, what they have in common is a factor of 16. I'm going to pull it out. When I pull it out, pull the sign with it. We're going to pull out a plus 16, okay? So plus 16, open the parentheses, divide 32x by 16, I get 2x. Divide 16 by 16, I get plus 1. Okay, so I can see that it worked out. I got a common factor, a new common factor of 2x plus 1. So I can pull that out as the new GCF overall, 2x plus 1. And if I divide both of these terms by 2x plus 1, I get x squared plus 16. Stop for a second. Are both of these things prime? Well, the first one certainly is. There's nothing you can pull out of it. And the second one, it's a binomial, but it's not the difference of two squares, so that one is also prime. So that's as far as that one can be taken. Okay, so now let's look at number 2 here. Number 2, again, let's just try the first pairing, the pairings as they are given. Okay, so something that you want to keep in mind, if this first term here for the second set of parentheses is negative, go ahead and actually make it plus, set your parentheses there, and then make it a minus, okay, because you don't want to chop off that sign. Okay, so on the first set of parentheses, do they have anything in common? And I'm going to look and go, oh, well, how about the variable? I can pull out an x squared. If I divide both of those by x squared, I get x plus 5. Okay. In the second one, remember we want it to match up with an x plus 5, and both of these things inside are negative, which means I'm going to have to pull out a negative GCF if this thing's going to work. So if I look at the numerical parts of it, I got a 4 and a 20. They have a common factor of 4. But go ahead and pull out a negative 4, minus 4, so that what's in the parentheses are going to match up. So if I divide negative 4x by negative 4, I get x. If I divide negative 20 by negative 4, I get plus 5. Okay? So now my new GCF is x plus 5, factored out. From the first one, what's left behind is x squared. From the second one, what's left behind is minus 4. Okay, so again, let's check to see if they're prime. This one's prime, and this one, oh, this one is the difference of two squares, so it can be factored a little bit more. So bring down the x plus 5. For the second one, difference of two squares goes x plus 2 and x minus 2. So now we have completely factored number 2. Okay, so why don't you go ahead and give these last couple of problems a try right here, factoring by grouping. Alright, so yours, I purposely mixed the terms up, give you a little added challenge. Okay, so on the first one, if you tried the pairings as they are written, the first two and the second two, each one of them, they don't have anything in common. Okay, but you can mix them up so that they do. Either put the A's together or put the X's together and Y's together, okay? So I chose to put the A's together, so AX plus AY is plus BX plus BY. So in the first set, A could be factored out, and the second set, B could be factored out, and it worked because I was left behind with the quotient of X plus Y. So the whole thing factors as X plus Y, and then times A plus B. Okay, likewise, the pairings as they initially are, they're out of order. Now what you could have done is just switch the last two, right? So that you have the x to the higher power followed by the x to the lower power. If you had switched those together, then that would have worked as well. I chose to just put the x cubed and the x squared together, and that one worked as well. So the first set had a factor of x squared, which I factored out, got x minus 6. And this one works because the next one has a factor of y, and you're left with the common factor of x minus 6. So overall, we have an answer of x minus 6 times x squared plus y. And those are both prime. You can't do anything else with it. All right, so that concludes our first set of lessons on factoring. We just factored by grouping, where the whole entire polynomial does not necessarily have a GCF, but if you pair them up in such a way, you might be able to pull out a GCF from each pairing, and then what you're left behind with might be a new GCF that you can factor out. Okay. We also factored binomials, and there were two cases. Either you had a difference of two squares, or you had the sum or difference of two cubes. And then finally, the first thing that you actually do, though, is you want to take a look to see if everything has a GCF, a greatest common factor, that you can pull out, because that makes what's left behind that much easier to factor. Okay? So, our assignment, I hope that you are able to print out this factoring worksheet. That's what we're going to be working on in class. Okay? See you in class.